Hey guys, what if your AI coding agent could run while you sleep and every commit actually works? Well, hopefully. We've all heard about the Ralph Wiggum technique, an autonomous coding agent that doesn't lose context. Today, I'm going to be showing you a really nice, easy and simple way to implement it in your workflow. The best way I think that you can do it. In this video, I'm going to cover three main topics. Firstly, the core principles of the Ralph Wiggum technique. Secondly, the three-phase workflow. And thirdly, a practical hands-on demo using a Claude Code skill.
That was awesome.
I've created a Ralph loop skill, which I'll link in the description. You guys can go ahead and grab this skill and plug it into your coding agent. This will help enable you to run the Ralph loop properly and set up everything you need. So let's go ahead and talk about the key principles. The first one that I've got here is that context is everything. The more tokens that you give to the LLM, the more dumb it becomes. For example, if it has a 200K context window, by the time you reach about 176K, it would be considered to be in the dumb zone, where anything further that you prompt is way too much for it to process and it starts giving worse results. Okay, we can see this in focus. Recently, a security researcher at Meta used OpenClaw. She gave it an initial prompt saying, don't remove anything from my mailbox. But after some back and forth, eventually it started trying to delete mails from the mailbox. That was because the context got too full and it forgot the initial instruction not to mess around with her mailbox. Originally, Anthropic released the official Ralph Wiggum plugin, which is a completely wrong approach. This is mainly because what it does, it launches one Claude Code instance, and within that instance, it goes through your bunch of tasks that you want the Ralph Wiggum loop to complete, but all the time, it's busy adding more and more tokens in the same session. The correct approach is that this should be a while true loop, a simple bash script that launches for each task a separate instance of Claude Code to complete that task, and once it's done, exit. The next is back pressure. So it's important that on each iterated task, you apply back pressure, such as like linting rules, passing tests, to ensure that the coding agent has done its job properly. The next core principle is let Ralph. This means lean into the LLM's ability, okay? It can identify the next logical task for it to work on, so that it can accomplish a full array of tasks well. The next part is to move outside of the loop. What this means is that your job as an engineer is to do thorough planning at the beginning. So you want to make sure the spec is correct, the implementation plan is correct, and once you've set that all up properly, you're going to step away and just allow the loop to iterate until all the tasks are completed. Okay, next, another thing a lot of people miss are the three main phases. Phase one is to define requirements. You have a bidirectional chat with the LLM, and what's outputted is a bunch of MD files, markdown files inside your specs folder. There'll be a detailed markdown of each component needed to fully build out what you're busy with. This is where it's your time to shine. You have to review those specs, make sure they're perfect, and continue until you're happy. Another important plan, which most people have missed, is the plan phase. Okay, so there will be a loop, but this time you give it a plan argument. What this does is, it does the Ralph loop, so this time it's the AI, but it's going to iterate over your spec. It's going to produce an implementation plan, which will be a bunch of checkboxes in granular atomic detail for each little task that the AI needs to write. Okay, once that's done, it's time to review the plan that it made, check if it's correct. You can actually delete that folder and run it again if you want to change your specs and get something that you're happy with before it's time for the AI to start building. So the next fun and exciting part is going to be the phase 3, which will be the build. This will be the build loop. It's going to iterate over task by task as small as possible to keep the context window as small as possible so that your AI can build out your full solution and you can sit back, relax while it's busy doing that or work on other things that are important. Okay, so let's have a quick look at the source code. The skill MD, the main thing that this skill is all about is facilitating the bi-directional conversation with you and also setting up your project structure. So the loop takes some arguments. If you want to run it in plan mode, put plan on. If you want to run it in build mode in phase 3, you omit the plan. The plan is going to tell it to make granular atomic tasks. So that's the most important thing about this prompt. The build, this is actually very cool. First, going to orient itself, so understand the plan. Next, it's going to choose a task. Next, it's going to implement and build it completely. Then it's going to validate it, and then it's going to update its implementation plan, and finally it's going to commit and exit the agent's MD. So here you're going to define how you want your test to be done, what kind of architectural patterns you want to do, what kind of linting, etc. you want to do. This is all going to be set up in phase 1 when you run the skill, so I'm going to show you how to do that next. Okay, cool. So let's go ahead and run the skill. I'll go ahead and I'll make a new directory called tracker. This could be anything. It could be that you're running the Ralph loop in an existing project. I'm going to use GLM, which is my ZAI settings. So I'm even using a slightly dumb model to do this, and it works fine. Next, I'm going to run Claude Code. And then all I need to do here is start the Ralph Wiggum skill. So once you've installed it, you can just start, and this will start the whole phase one, the bi-directional planning phase. It's going to go ahead and it's going to set up the project and everything it needs to do. It's understanding that you want to do this phase. So it's going ahead, it's reading the scripts, and it's going to scaffold everything that it needs. So it's created the loop file, the prompt plan, and the prompt build. Okay, now it wants to understand my project. So here's your time to shine. It's your time to build out the spec with the AI. So what I'm going to do here, I want to create, let's call it 8-bit tracker app, web app with a synth and a tracker that I can record and modify sound waves. So actually, I've already gone and done this. I'm just going to do a quick example of this bidirectional conversation. Then I'll go and show you what I actually built, and I was really satisfied with the results. So it's going to have this conversation, what kind of synth, etc. are you envisioning? And then you're going to go ahead and answer all these questions. So Moog 1980s to tracker with columns and rows, as each track is a column, each row is a beat. You can adjust the BPM and record your instrument. Just continue the conversation. The more detailed, the better. So 1, it can be 4 with adding. 2, it can have adjustable. 3, select cell and record, no live record. So now it's going ahead. It's going to create for each component a spec, and then the plan loop will iterate over the spec and create the granular tasks. Again, you should do this in much more detail. I'm going to add something here is I want to use functional paradigms and TDD. Each task should complete a test. Test should be written first, and strict TypeScript lint rules added to the agent MD. Using patterns like this will really create better results in the end than just letting the AI go rogue. Okay, cool. So it's created the spec. Now what it's doing, it's recommending to you that you should go and review the spec very thoroughly, and then you can carry on having some back and forth with it. So I'm going to go and exit this, and let's have a look. We can have a look at the spec that was produced, but I'm not going to spend time. But what's really important that you review the spec and that you're very clear about what it needs to build. This is the most important part for you. For now, I'm not going to worry about it. What I am going to do, I'm going to run the loop in plan mode. So you add the plan argument. If you want to have a look at it here, you add the plan argument like that. Okay, now, so you can go and have a look. Here's the prompt for the plan phase, and it's running in a loop already so that it has a clear context from the conversation. It's going to do a wholesome analysis of your specs, and this prompt is very clear. It says that it needs to create atomic granular tasks. So it's created implementation plan with 22 atomic tasks across 8 phases. 22 atomic tasks seems a little bit too few. So again, this is where you can scrap your plan. So we can go and have a look again. Now you can see that it's created an implementation plan. This is where you might want to re-instruct it. Just make sure that your implementation plan is good. Again, you can delete this folder and then just run it again. But for now, I'm going to go ahead and run the loop like this. So now we're going into build mode. It's going to iterate over each one of those tasks. It's going to choose a task. We just watch one iteration. It's chosen which task it's going to work on. You can see that it's going to do each phase. So first it's going to orientate itself. Then it's going to, in its workflow, do task declaration. So it's going to choose one task to work on. Then it's going to go ahead and build the task. And now I think it's on its validation step. It's making sure that everything installed correctly. And now it's in its update the implementation. Now it's checking the Git workflow, whatnot. And it's busy adding a commit. So now it goes, it exits, and then it's going to start on loop 2. And it's going to go through the same workflow. I've actually built this project already, and I'm going to show you what the results were. And this was actually what I built before. I was really happy with this. It's actually pretty awesome. I'm going to turn my desktop audio on. We got the first sound, so I'm going to go and create a track. So as you can see, the vibe coded app is a little bit rough, but it's working really well. So I'll try and make a little song with this quickly. Let's see what happens. Nice.
That was awesome.
Okay, so yeah, let's go back. We can have a better look at the actual spec file that I used to make this. So again, you'll see like I really spent some time refining this and making sure it was all perfect. I really defined how I wanted my architecture to be It really got into detail when I had the bidirectional conversation with everything. We can also go have a look at the implementation plan. So here you can see all the granular tasks that it ran and completed. If I go and actually show you even what the process looked like, I can find the history. So here you can see all the commits that it actually did to accomplish this task. You can see it committed a lot of things. You can go back, you can see each task it completed. It first did the package JSON, byte config, etc. Then it started setting up the project, etc., etc., etc. I feel like if I had coded this myself, because it's something I would actually love to code myself, I would put a lot more love and care into it, but I shouldn't be too prideful to say that it wouldn't be a challenge. The AI pretty much aced this really well. What's really cool, like I could just run this in the background. I went and took my dogs for a walk, came back, saw the progress, and now I can make this really cool video about it. And I've made a really fun little tracker tool. If you were to just look what one iteration would do, it would do one task and then it would run the tests to make sure that all the tests are passing. Let's actually run the tests just to see what they all looked like. We can take that and say npm test. You'll see how cool it is. Like, so it actually has 520 passed tests. I really recommend this approach. I used functional paradigm and I used test-driven development, and I used strict linting rules. You can probably see that if you look at my agents MD file. So it was all specified here how it needs to work. Functional paradigm TDD. Cool. So let's have a quick recap. Number one, we discussed the 4 key principles. Principle number 1, context is everything. It's all about destroying the context rot problem, having a small granular task for your AI agent to work on. And you want to have a clear context window for every iteration to use the most of the LLM's intelligence and get it focused on small details. This ensures the best results. Like I used GLM and outputted such an amazing output, even though GLM has such a small context window. Number 2, steer with patterns and back pressure. So that's we discussed in the agents MD file. It gets steered with these important rules it needs to follow, such as making sure the tests pass on each task, defining your kind of architectural pattern that makes sense for what you're busy building, even your frameworks, your coding languages, your libraries, or you should have some knowledge of this in order to guide the agent in the correct direction and build things the way you want it. Number 3, let Ralph. You'll reach eventual consistency through iteration by just choosing the next logical task on each iteration. Eventually it'll build out the full solution. Okay, and then the 4th important principle, move outside the loop. Your job is in phase 1, it's the planning phase, it's building out the specs. That's where you need to shine. And then you must just let the loops loop. Okay, you need to step back and let it do its thing and have a look what's created at the end. Okay, next we covered the 3 main phases. Again, you first have the define your requirements phase. Then you have the planning phase, which is also a loop to create the implementation plan. And then you have the build phase, which is each iteration implementing a task. Okay, and finally, we went through a practical example of building out the solution. Let's go have a look how our agent's currently doing. Hopefully I can get it to load here. Our little thing is now on its 11th iteration. And you can see it's busy going through loop by loop by loop. It's still busy running in the background like I quickly did for the demo. And I've shown you what I built off of the camera. Okay, so that's it for today. Let's record another cool little track for this video. Well, there you go. I hope you enjoyed that. That's the Ralph loop done correctly. Use a skill. It should have originally been a skill. I don't know why they tried to make a plugin. The skill just facilitates it much better. Bidirectional conversation, spec out your project, scaffold everything that's needed to run the loop properly. It's a simple while true loop, right? Come boy. Guys, thank you so much. I hope you enjoyed this. If you did, give it a like and subscribe. It's really going to help my channel to grow and I can keep on making fun content like this. I hope it is helpful to you. Remember to check out the source code for this skill. You can use it in your projects.